Welcome dear learners. We are continuing Unit 5 Inorganic Practical 1 Volumetric Analysis. In the present module we are focusing on importance of lab safety. The contents of this module are lab safety, precautions and preventive measures, first aid for burns, eye accidents, cuts, gas poisoning and electric shock. Double burette method of titration is also discussed here, and there is a description and demonstration of this double burette titration is also included in this module. First of all, lab safety. Laboratory safety or lab safety is essential in any scientific environment, especially in chemistry labs where hazardous chemicals, glasswares and instruments are frequently used. Laboratory safety is crucial to ensuring a safe working environment for all individuals, teachers, students, lab staff, all conducting experiments and handling chemicals. Creating awareness about safe laboratory practices and first aid measures is very essential for safe laboratory experience. That is, we all should know about the lab safety measures that we have to adopt whenever we are doing experiments in a chemistry laboratory. In chemistry laboratories, students deal with a large number of chemicals. These chemicals must be used with utmost care as these are dangerous for human exposure. That means, for example, whenever you are taking sulfuric acid, concentrated sulfuric acid, if it spills on your skin, definitely there occur burns. So, similarly, there are so many kind of toxic materials in the laboratory, and an awareness about the toxicity of such a material and handling of such chemicals is very essential for a smooth performance in the chemistry laboratory. Why lab safety is important? This is a very crucial question as far as this module is concerned. The lab safety is very significant because of these following statements. Protection from chemical hazards, prevention of accidents and injuries, avoidance of contamination, fire safety, environmental responsibility. These are very important parameters that necessitates the lab safety. Protection from chemical hazards is very important as far as any individual in the chemistry laboratory is concerned. The lab safety protocol help us to prevent from various kind of accidents and injuries. This lab safety steps helps to avoid contamination. It helps us from fire. The lab safety procedures is also very important as far as the environmental responsibility of ourselves and all individuals are concerned. Now, precautions and preventive measures. We are now discussing about various precautions and preventive measures that you have to adopt whenever you are entering into a laboratory, especially a chemistry laboratory. General precautions are described here. Always read experimental procedures and chemical labels before you start your experiment. Conduct experiments under supervision or in the presence of others or responsible members. Know emergency procedures. This is very important. You have to familiar with the emergency procedures that you have to adopt in the case of an accident or an emergency. Wear personal protective equipments or PPEs. the important personal protective equipments that you have to wear in the chemistry laboratory include lab coat, goggles, gloves, shoes, etc. Now, handling chemicals and equipment safely. You have to use spatula to take some chemicals, and you have to switch on and switch off the electrical equipments with very precaution. Cleanliness and waste disposal is also very important as far as the general precautions that you have to adopt in a chemistry laboratory is concerned. Now, safe handling of chemicals. Read labels and safety data sheets or SDS. For every chemical reagent in the laboratory, there is an associated material safety data sheet or simply safety data sheet. Each individual has to go through that safety measures and safety data sheet of every chemicals that you are going to work with. Understand hazards, handling and disposal methods for each chemical helps you to protect from some emergency situations or accidents or contamination with that chemicals. Use chemicals in proper quantities is very essential. Don't waste the chemicals. Excess amounts can cause dangerous reactions. Now, never smell or taste chemicals, and in case where you have to identify a particular compound by its smell, you can use procedures or techniques like wafting to detect the odor. As during dilution of acids, this point is very important. Add acid to water, not water to acid. This prevents splashing and dangerous reactions. Equipment and glassware safety is also very important concern. To smoothly conduct experiments with the glasswares and equipment, you can follow these instructions. Inspect glassware before use. Turn off equipment when not in use. Handle hot equipment with caution. So, you have to take glasswares. Before starting the experiment, you have to just make an inspection whether it is broken or cracked. If some crack are noted, you just replace with a fresh one. Turn off electrical equipments when not in use. And handle hot equipments with the caution. That means you can use heat resistant gloves or tongs to handle such hot equipments. Fire and electrical safety is of prime importance as far as a laboratory is concerned. Know fire emergency procedures. Locate fire extinguishers, fire blankets and emergency exits in your chemistry laboratory. Keep a flammable substance. Flammable substance means these are materials which can easily capture fire. Petroleum products, you are familiar with the highly inflammable nature of the that petroleum fuels. Keep such highly flammable materials away from open flames. Store them properly to prevent ignition. Now we are focusing on the rules for general laboratory conduct. Clean spills and splashes immediately. Dispose waste properly. No eating, drinking or application of the cosmetics in the laboratory is very essential, and work under supervision. These are about common laboratory conduct, or these are some popular statements or some important concerns that we have to adopt whenever we are working in a chemistry laboratory. Preventive measures are other part of the discussion. Before starting the lab, we have to take some preventive measures like wear personal protective equipments, check instrument for faults, ensure ventilation, whether the ventilation in the laboratory is adequate, and after finishing the lab, you have to look on these points. Turn off gas, water and electrical connections. return chemicals into storage space where it was previously stored, clean workbench and your hands. Now, the next part of the present discussion is about first aid. You are all familiar with the concept of first aid. First aid refers to the immediate medical assistance given to a person suffering from an injury or illness before professional medical help is available. This is a definition that I am telling here to remember the concept associated with the first aid. The concept of first aid we have learned in previous modules, and we can just take some first aid for emergency situations like burns. First of all, we are discussing the first aid for burns. For minor burns, you have to adopt this procedure. Wash with tap water followed by ice cold water, or use ice pack and then apply suitable antiseptic cream. Apply sodium chloride paste or slurry and then apply wet gauze or cloth. For severe burns, you have to first remove any tight clothing near the burn site if not sticking on the skin. Wash with the tap water followed by ice cold water, and finally you have to seek immediate medical attention. Now we are discussing first aid for eye accidents. For eye contact with acids or alkalis, adopt this first aid. Immediately flush the eyes with sterile, saline or clean water for at least 15 to 20 minutes. Keep the eyelids open while flushing. Don't use neutralizing agents or chemicals in the eyes. Now, if the person wears contact lenses, remove them carefully after initial flushing. Seek immediate medical attention even if symptoms improve. Now we are discussing first aid for cuts. Cuts caused by broken glasses are common in laboratories due to the usage of glasswares like beakers, test tubes, pipettes, etc. Immediate and proper first aid can prevent infections, control bleeding, and promote faster healing. For minor cuts and bleeding, you have to adopt the following procedures. Let it bleed for few seconds. Wash with water. Apply a disinfectant like Savlon or Dettol, followed by an ointment, or apply dilute perchloride solution or tincture of iodine. You have to keep the fact that dilute perchloride is highly able to prevent bleeding from minor cuts. Now the first aid for major cuts and bleeding. First of all, you have to wash with disinfectant. Try stopping bleeding by applying pressure to close the wound. Consult a doctor immediately. That is the immediate stage. Now, first aid for gas poisoning. Move the victim to an open place. Do not crowd around the victim. Loosen clothing at the neck. This is to ensure proper respiration. Provide oxygen and breathing assistance. If the person is unconscious and not breathing, then you have to immediately begin CPR. That is nothing but cardiopulmonary resuscitation. Inhale dilute vapors of ammonia or gargle with sodium bicarbonate solution. Now we are discussing about first aid for electric shock. This is the first step. You have to ensure safety of yourself. Don't touch the victim if they are still in contact with the electrical source. Turn off the power source immediately if possible. If you cannot turn off the power, use a non-conductive object to separate the victim from the source of electricity. This is the second stage. Check responsiveness of the victim. Look for breathing and pulse. In the third step, you have to provide CPR, that is cardiopulmonary resuscitation. If the victim is unresponsive and not breathing, start CPR. The fourth stage is seeking of the medical attention. Call emergency services immediately, and especially if the victim is unconscious or has stopped breathing, there are severe burns, and if the victim experiences chest pain, irregular heartbeat, or difficulty in breathing. Now, as a last part of the discussion, in this module we are focusing a very important titration method, that is nothing but double burette titration method. Double burette method of titration. This double burette method of titration is a titration method using two burettes without using pipette. In our common titration procedures, we are using one pipette and one burette. However, in the double burette method of titration, we are not using a pipette, but we are performing the titration with the two burettes. The principle and procedure of the double burette method can be illustrated by taking the simple titration, that is the titration of sodium hydroxide against hydrochloric acid. For this purpose, for the illustration or for the discussion of the experiment, we have to set two burettes first and take burette 1 filled with hydrochloric acid and take another burette 2 filled with sodium hydroxide. So, for performing the titration of NaOH against HCl, you have to take two burettes, burette first filled with HCl and burette second filled with the sodium hydroxide. Now, take 16 ml. This quantity may vary. This is a generalized quantity. For the sake of convenience, we are fixing it as 16 ml. Take 16 ml of the base, that is sodium hydroxide, is added to a conical flask from burette 2. Remember, burette 2 is filled with the sodium hydroxide, and you have to drain 16 ml of sodium hydroxide from burette 2 into a conical flask. Now add one drop of indicator. You can use either phenolphthalein or methyl orange. Any indicator is sufficient because you are dealing with a strong acid, strong base titration. And now it is then titrated against hydrochloric acid, which is taken in burette 1, and record the end point. The end point depends on the nature of the indicator selected for the titration. Now, from the titer value, we can calculate the normality of unknown concentration using the relation VNaOH into NNaOH is equal to VHCl into NHCl, where VNaOH and VHCl represents the volume of NaOH and HCl, NNaOH and NHCl are corresponding normalities. To the solution left in the conical flask, 2 more ml of sodium hydroxide is added from burette 2. It is again titrated against HCl taken in burette 1 and determine the end point and calculate the normality by using the previous equation. The process is repeated for 20, 22 and 24 ml of sodium hydroxide, and normality is calculated in each step. The average of all these values of normality is taken as the normality of the unknown solution. Now, in the double burette method, you can also plot a graph, or a graph can also help in finding out the end point and the final normality. That is, we are now just discussing the graphical method. Alternatively, a graphical method can also be adopted to determine the unknown concentration. Here in the present experiment, the volume of hydrochloric acid against volume of NaOH at each end point is plotted. This will gives us a straight line because the volume of HCl is proportional to volume of NaOH, so you will get a straight line. The titer value corresponds to any definite volume of NaOH is obtained from the corresponding point in the graph and can be used to calculate the normality. Now we can illustrate the same experiment, that is titration of sodium hydroxide with hydrochloric acid can be done by using the double burette procedure. That is, we are going to demonstrate the double burette titration method. titration method. That all about the present module. Have a nice learning experience. Thank you.